Ladies and gentlemen, we'll get started in about 5 minutes. 5 minutes until the start of the event.
move it to the side, okay? Oh, that's okay. That's fine. It's okay. I'll move my stuff out. I'm just positioning myself. Good. Okay. We're going to get started in just one moment. Welcome. Can everybody hear me at the back? Barbara, can you hear me at the back? Wonderful. We're going to get started. It's about 9:06. We're just a few minutes behind schedule. Respectful that everybody has very busy days ahead. Good morning. My name is Sally Bennett-Olzak. I have the great honor and pleasure to serve as the CEO of the Alzheimer Society of Windsor and Essex County. This is our first ever research day, and our board of directors is offering this day to our community. Research is currently underway around the world for a cure for Alzheimer's disease and also the treatment of Alzheimer's disease and related dementias. Today we're showcasing both national level research from our Alzheimer Society of Canada office, which is located in Toronto, and proudly also local research from the University of Windsor. We're delighted to share this event with you at Art Windsor-Essex, and Art Windsor-Essex has been particularly gracious in letting us utilize their wonderful event space. An exceptional view of Detroit River, the GM Renaissance Center behind us, and Detroit River, downtown Detroit as well. Karen, where are you, our board chair? Karen Hall, right here in the striped dress with the black jacket. Karen Hall, many of you will know Karen. She's here to welcome all of you on behalf of the Alzheimer's Society of Windsor and Essex County as our board chair. 5 years serving in that capacity. Thank you, Karen. It's also our great pleasure to welcome Dr. Robert Gordon, right here at the front. Thank you for being here. President and Vice Chancellor of the University of Windsor. We know you have a busy day ahead, so thank you. And Dr. Shanthi Johnson. Dr. Johnson, could you stand so we can see you as well? Thank you, Dr. Johnson, for being here. Delighted. VP of Research and Innovation from the University of Windsor. Should be so proud of our researchers locally. Our organization continues to enjoy a robust and beneficial partnership with the University of Windsor and its students. I'm very excited to introduce our esteemed researchers who will be presenting to you today. Very quickly, Dr. Joshua Armstrong is right here at the front. He is our research scientist, Alzheimer's Society of Canada, and we welcome Dr. Armstrong, who flew in from Thunder Bay yesterday. He'll be with us till tomorrow evening. We put together, and thank you to Eugene Van Wyck. Eugene's here, our Manager of Fund Development, Community Engagement. He put together a total eclipse of the sun for your arrival yesterday. Unfortunately, Dr. Pearson was waiting for his flight at Pearson International Airport during the eclipse, so he stood at the window and looked out and saw the eclipse. So we're sorry about that, but we warmed him up in the evening at a local brewery and had a lovely evening together, our team, in the true Windsor-Essex spirit. Dr. Jerome Cohen, known to many as Jerry Cohen, from the University of Windsor, was instrumental in us putting this day together, and he is in our prayers. He's in intensive care unit, having had heart surgery, and he's in London, and it's a little touch and go. So we're asking for everyone's prayers, and I know that Dr. Cohen is here with us today, very much in spirit. We have Dr. Siyaram Pandey from the University of Windsor here as well. Thank you, Dr. Pandey. And the future Dr. Keanna Dube, Ms. Keanna Dube, doctoral candidate research assistant from the University of Windsor, who will be presenting as well. I'd suggest that we have 3 generations of researchers presenting. How proud we are. Please find their detailed biographical information in your packages. Everybody should have a white package with lots of info. It highlights their esteemed past and continued careers. Housekeeping, the washrooms are out the back to the left. Feel free to help yourself to refreshments here or take some from the road in the true spirit of the Alzheimer's Society. As for the orders of the event, each researchers will be presenting, and then we'll have Q&A after the presentation. Feel free to remain after to speak with our researchers, and certainly time of fellowship for all of us here at the Alzheimer's Society. We're live streaming today. Welcome to those who are joining us from far and wide, and thank you to Francois Jacques of Mac Flash, who's put all the technology together. Video will be available later for us to watch, so we'll be repurposing this information over the next year or two. With that, it's my great honor to welcome Dr. Joshua Armstrong to the podium.
Are my slides up there? They're here. Oh, just a little tech support. Thank you so much for coming out today. We're very happy to be here. There we go. Yep. Perfect. So thank you for coming out today. I'm happy to be here from Thunder Bay, Ontario. I'm here to talk today about the Many Faces of Dementia in Canada, the recent report that came out from the Alzheimer Society of Canada. I won't have enough time to go into full detail, so I'm just going to briefly take you through the different sections of the report. We've known for a long time that we expect the population of people living with dementia in Canada to grow. You saw this back in 2010 when the Alzheimer Society of Canada produced the Rising Tide report. And with this landmark study, we wanted to update some of those trends to look at what do we expect for dementia in Canada over the next 30 years. A lot of this is driven by the aging of the population. As I showed here, what once was an aging pyramid now is some sort of odd shape that we don't have a good descriptor for. From the landmark study, we have 3 reports coming out. 2 are already available. The first one, Navigating the Path Forward for Dementia in Canada. We looked at population projections and the potential impact of prevention activities. What could we do across the population to reduce the risk and how that would play out in the future. Today, I'll be talking about the Many Faces of Dementia in Canada. This is where we're examining the people experiencing dementia over the next 30 years, breaking down those projections, looking at different population groups. Both of those you can find on our website. I think you might have them in your packages as well. And then we'll be following this up with a third report when we layer on economic data to look at the economic impact of dementia over that same time period. So for these analyses, we used a micro-simulation model. We worked with the Canadian Centre for Economic Analysis, and what we did was create a micro-simulation to get a better sense of what the trends might be playing out over the next 30 years. What a micro-simulation model is, we basically use data to recreate the Canadian population. So each and every individual Canadian exists within the data set. They're called an agent, and they're able to live and interact and develop different health states. So we can map that out, and just like you would do in SimCity or in other simulation games, you can press play and see what kind of the future will play out if those trends continue. So we do that here to try to get a better sense, and we could break it down in different areas to get an understanding of differences between the sexes, ethnicities, differences across the provinces, all while accounting for population dynamics, things like immigration, death within the population, and birth, although birth doesn't play too much into the role within dementia itself. So from the first report, here are some of the estimates that we can see. By 2050, expecting the number of people living with dementia to grow to almost 1.7 million people. That's a 187% increase over that time period. The model estimates that at the start of this year, there were 733,000 people living with dementia in Canada, and by the end of the year, that number increases to 772,000, with 145,000 people developing dementia during those 12 months. Several factors play into this kind of landscape of dementia in Canada and how it will change. Primarily, it's driven by the aging of the population. Baby boomers amongst us are all getting into their late 70s, and during that time frame, going into their 80s and 90s. With that large number of people getting into their older years, that really drives with some of the increases that we see. We also capture within the data evolving immigration patterns, so you'll see that play out in some of the analyses later in the presentation. There also have been changes in population level risk for dementia. We've actually seen many improvements over the last couple decades. So if you actually control for aging, people are actually developing dementia at a lower rate. But because we have that large baby boomer cohort getting older, we still expect those numbers to increase fairly dramatically in the years to come. Now, this is a microsimulation model. It's not a crystal ball. It doesn't actually tell the future. It just takes current trends and kind of projects them out to see what we would expect during that 30-year time period. We don't know how things will change during that time frame. Will risk factor levels change? Will we have new treatments? We're seeing some treatments kind of come through. Will those improve and get better and actually make an impact on these numbers? We don't know how climate change will impact us. We don't know how the pandemic will impact these numbers. There's no COVID-19 data included in these models whatsoever. We don't have that kind of quality of data to kind of influence our model quite yet. But if we do follow the current trends, this is what we expect to see. The dark blue bars, that's the prevalence or the number of people living with dementia, growing up to 1.7 million by the end of the time frame, 2050. The light blue bars, that's the incidence or new dementia diagnoses or cases that we'll see across the population. You can see that steadily increasing. And by 2050 or 2040, those numbers are expected to be over 250,000 individuals per year developing dementia. So almost a doubling of rate from 2020. So if you do the math, that's almost 21,000 each month, or 700 every day, or 30 every hour in Canada, people developing dementia. If we follow these current trends, and we count up the number of people that are expected to develop dementia over that 30-year time period, that's 6.3 million Canadians who will experience the symptoms of dementia in the next 3 decades. So a large number of people growing every day over that time frame. This leads us to what I'm talking about today, the many faces of dementia in Canada. So with this understanding of the increasing size of people living with dementia, well, I think now is an important time to get a better understanding of the diversity that we see within the population of people living with the condition. What we've tried to do with this second report is really literally and figuratively put a face to those numbers. It's really easy to think about 1.7 million as just being a statistic, but that's 1.7 million stories that are impacted by the condition, by this brain condition. So we've tried to break down the numbers into different population groups, but also across the report, we've included stories of individuals, people living with dementia or their care partners, to really put a face to these numbers and make sure that people understand these are individual stories being affected by the condition. There's 5 aims to this report. We want to increase the awareness of the diversity that exists within dementia. We want to improve the public's knowledge of dementia itself. I live and breathe dementia every day, but the more you talk to people who don't live in this space, they don't understand it, they don't get it. So trying to really educate people about what dementia is, what are the risk factors, and how can we work to prevent it. We want to advocate for better dementia care for all Canadians. We want to create action towards inclusion, equity, and diversity within the dementia space, and also push for change, more research dollars, more research, more focus on diverse communities, and better care for all Canadians. There are 4 main topics within the report. I'll cover each one of these individually over this presentation, sorry. First, we begin with dementia and Indigenous populations. Second, we then look at differences across ethnicities and racial groups. Third, looking at sex and gender differences. And we'll conclude today with a look at young onset dementia, or people under the age of 65 who developed the condition. So to begin, dementia and Indigenous peoples. So for this model, we looked at 2016 census data, and if we look at that data, over 2.1 million people reported Indigenous ancestry. And if we break down Indigenous populations in Canada, usually we look at 3 main groups: First Nations, Métis, and Inuit. Often we think of these populations as being younger. They do have a wider population base when it comes to that age pyramid, but also they are considered aging. They have a growing number of people over the age of 65. With age comes increased risk of dementia, age being the #1 risk factor for dementia. So when we looked across a range of topics when we were talking about this data, one of the things that we highlighted was this idea of social determinants of dementia. And when we're talking about Indigenous populations, we have to also talk about the impact of colonization. So we borrowed this model from Lopi and Wien that uses this tree analogy to look at how people's contexts will influence health outcomes. And this holds true for Indigenous populations, but for all populations. Often in the dementia space, we think about individual health behaviors and forget about the context in which people live, but the context is highly important when it comes to all health states, including dementia. So we shouldn't just focus on health behaviors. We need to think about the systems that we live in and the influence of all factors. And for indigenous populations, the impact of colonialism is huge. It impacts not only dementia, but also all the risk factors for dementia as well. We also highlight the role of chronic stress and how that impacts brain health. For indigenous populations, this comes from everyday racism that people experience, but also lack of economic, lack of work, lack of some housing issues. So there's different ways that people can experience stress, and when that stress is chronic and happens every day, we've known for a while that it has a negative impact on the brain, but more and more research is showing how that negative impact over a life course leads to worse cognitive health outcomes and higher dementia rates amongst different populations. We can also look at how racism can play a role in terms of not just in a barrier for good health care, but also a barrier for good dementia care. And we conclude the chapter highlighting some resources that are developed by different Indigenous groups within Canada that can be used for things like assessment and just communication and trying to reduce stigma within the Indigenous populations. So when it comes to the numbers, we can see that for Indigenous populations in Canada, we expect a 273% increase over that time period. So going from around 10,000 individuals up to about 40,000 individuals. And these are probably what could be considered a conservative estimate. We know that StatsCan data often undercounts Indigenous populations in Canada, so these numbers are probably higher than what we're sharing. But again, we don't want to just focus on the numbers, so we also embed stories of Inuit, Métis, and First Nations individual within the report, so you can read about their individual experiences living with dementia or taking care of their family members. The second chapter looks at breaking down across different ethnic groups or racial groups in Canada. We look at Canadian data, that 2016 census again, over 250 different ethnic origins were recorded within that data. I have a background in gerontology, so studying older populations, and we recognize that older population in Canada is becoming more diverse, different groupings of ethnicities within it. And that same thing holds true for people living with dementia. We have a shift in the ethnic background of people living with dementia in Canada, and you'll see some of that play out in the results at the end of this section. If you look at data from the US and the UK, consistently we find differences across different ethnicities in terms of dementia risk. So we don't have much of that data within Canada, and we need to work on that, but the US and UK both show that not everyone is at the same amount of risk when it comes for developing dementia. The model itself, the landmark study model, was influenced by a study by Maeda, looked at 6 different groups in Northern California, and found that there was almost 60% variation could be explained by ethnicity within her findings. Why do these differences exist? Well, I think we need to do a lot better research to try to better understand that, but I can offer some ways why that might occur. There are potential disparities in terms of risk factors for dementia across groups. It's well established that things like diabetes, heart disease differ across different racial groups, and that those will also have an influence on dementia outcomes across populations. We also need to think about the social determinants of health and how they play a role in dementia risk, and also how there could be differences in genetic risk factors and biomarkers across different ethnic groups. We also should recognize that people from racialized communities can receive poor quality of care and may also receive diagnoses later on their disease trajectories. It's also widely established that diversity is missing in dementia research overall. A lot of the research that has already taken place focused on well-educated white populations, and it can't really be generalized to the diverse population of Canada. So more work needs to be done to diversify and include more representative samples in dementia research. And this is widely recognized, and lots of work is being done to try to address this finding. And when it comes to the landmark study data, here we have 2 pies. Each pie represents the population of people living with dementia at 2020, and then the larger one at 2050. And the biggest shift that we're going to see in terms of ethnicity is in terms of people of Asian origin. So 8% of people in 2020 living with dementia, they were from Asian countries, East Asia, South Asia. By 2050, that goes up to almost 25%. So by 2050, 1 in 4 people living with dementia will be of Asian origin. So we need to try to address our programs and policies to try to address this fact in terms of language, in terms of culture, recognizing that there is this shift in the diversity of people living with dementia in Canada. So here's kind of what drives that differences. This is a percentage increase in the number of people living with dementia from 2020 to 2050. And that top line, the orange line, it's hard to see with this light, but that's the Asian population. It's not because Asians are at greater risk. Not at all. Actually, if you actually look at the data, Asians are actually at lower risk than most. It's the fact that it's a demographic thing. We had a shift in immigration back in the 1970s, and that's continued. So we have more Asians coming over during that time, and those individuals now are getting into their 80s and 90s. So it's really the aging of the Asian population, which is always hard to say, Asians. But that's really what drives the numbers up. So it's not about differential risk in this case. Again, there is these differences in risk, but what really drives a lot of the numbers is the fact that people develop dementia in their 70s and 80s. They can do it earlier as well, but age is the highest risk factor for dementia. And of course, want to put a face to these numbers too. So we here, again, share stories of people and their experiences with dementia. The 4th chapter, sex and gender differences in dementia. If we look across all high-income countries across the globe, females outnumber males in terms of dementia numbers by a rate of about 2 to 1. So about 2/3 of people that develop dementia are female. When we look at the data, factors that are both related to sex and gender can shape a person's experience from their risk before symptoms start all the way through treatment and beyond. Here in this table, I break down sex and gender factors that might play a role. Sorry, I'm not sure. This might keep slipping. That might play a role in dementia risk. So you could think about things, biological things like brain structure and stress responses, how that might play a role. But then also think about things like education and occupation from a gender perspective and how that will influence people's risk. And when you think about that gender perspective, that shifts with time. Different generations have different experiences in terms of education and occupation for genders. If you think about my grandparents' generation, many of those women didn't even work, they worked at home, didn't have occupations. Then my mother working, and then even changes for my generation, and it'll continue to change. So we have to do research to try to understand how that impacts dementia experiences. If we try to understand why there is this large difference between the sexes, often it's attributed to the fact that women live longer than men, and with age being the strongest risk factor, that explains it. So in Canada, women live on average 4 years longer than men. So that does explain some of it, but doesn't explain all of it. It's much more complex than that. There is data from the UK and the US. When you control for age differences, you see that men and women have the same amount of risk in the US, for instance, but if you go to the UK and control for age differences, women still at higher risk compared to men. So that tells me that there's more complexity within this, and you need to look at much more things, both sex and gender, to try to better understand that. So here in this table, just highlight some of the sex differences that we find in dementia, but we could also think about gender as well, and how gender roles can influence people across the life course, whether it's in terms of level of education, occupation, and other factors. We also highlight in this chapter the impact that dementia can have on people's identities and how it can often be consumed by dementia diagnosis. So work from Lakehead University up in Thunder Bay, where I come from, Elaine Wiersma is focused on that, and she has wonderful work looking at how dementia diagnoses can actually consume people's identities. So no longer are they a grandmother taking care of their family, but they're a person living with dementia, genderless. So there's lots of work to be done there as well. We can also think about caregiving and how men and women are different and have different needs in terms of providing care to people living with dementia. And much more research is needed on the experiences of non-binary, intersex, and gender diverse people. We don't really have any information or data on how that works. The table on the right you can find in the chapter it breaks down kind of differences in the clinical presentation based on sex and gender, and how that can influence things from even the assessment of dementia, and how gender can actually influence whether dementia is picked up by a clinician or not. So here are some results from the model. You can see that across, if current trends prevail, almost 2 of every 3 dementia diagnoses in Canada will go towards women. And the stat that people like to focus on is by 2050, over 1 million women in Canada will be living with dementia. Of course, we'll also embed some stories within this as well. So here, Tyler talks about his grandmother and the experiences that he had with her, taking care of her. And the final topic for my talk today and from the reports is young onset dementia and some of the distinct challenges that people who develop dementia under the age of 65 can face. So young onset represents a term that is used for those people that develop dementia at an earlier age. You also might see the younger onset term. I've seen Alzheimer's Disease International use that. But it's kind of replaced this term early onset dementia because there can be confusion. If you say early onset, it gets confused with early stages of the condition. So young onset or younger onset, I think, is a better term. The term's new, but the condition this condition is not. If you actually look at the first cases of Alzheimer's disease, they were both individuals in their 50s. And actually, the history of Alzheimer's disease and dementia is quite fascinating. It wasn't until the 1970s that we started considering people over the age of 70 to actually have Alzheimer's disease. Before it was called senile dementia or just senility, right? So things change over time, but we have this term now, young onset dementia. And so people do develop dementia earlier than the age of 65. Usually it's between 50 and 65, but it can be even earlier than that. But when you develop dementia at that age, it comes with unique challenges. There's a larger number of symptoms, a larger number of causes for young onset dementia, which can lead to a later diagnosis, which can lead to problems of care. There's also a lack of awareness among clinicians about young onset, so it often takes a long time to get that diagnosis because it's hard to recognize what's causing that young onset. But also, if you think about the time in the life course, someone could be 55, still working a full-time job, having children at home, and then so that leads to a whole range of different care than if you were 75. All right, so things need to be, we need to develop systems to support individuals who develop dementia at these earlier ages. So the numbers aren't as extreme from the model for young onset because it's not driven by the age of the population, but we still, tens of thousands of Canadians still experience dementia under the age of 65. So here highlight some of those projections, but also include stories from individuals and their experiences with dementia at earlier ages. So when it comes to wrapping the talk up, we have a conclusion chapter and really want to emphasize that diversity in dementia doesn't just stop at these 4 topics I covered today: indigeneity, sex, ethnicity, and age. There's much more to individuality and diversity than just those topics. You can think about sexual orientation and how that plays a role in dementia risk, care, and the support people receive. But also there are dementia experiences of people with intellectual and developmental disabilities, and that can play a role in their experiences and how we assess their state of cognition and how the care that they need as they get older. We also can think about our prison population and how they're aging as well and have unique needs and challenges. How do we, if someone finishes prison sentence at age 70 and goes out but also has dementia, what are the supports there available for them? There's lots of challenges there. We can also think about homelessness and how that's a growing challenge and how that's related to dementia as well, and also substance abuse and how that plays a role in the brain health of all Canadians. We are all unique. We all have these unique stories, but it's our shared characteristics and our shared differences that are important to recognize when we're trying to plan future supports across the population. In the final section of the report, we try to bring attention to some of the opportunities we have to optimize care for individuals. We can't really expect a cure or effective treatment anytime soon, but there's lots of things that we can do to have positive outcomes on people who live with dementia and for the brain health of all people who live in Canada. So we do that by listing out a range of recommendations. I don't have time to go through, I think it's like 52 recommendations. We break it down by different lenses and by the different topics. So what can we at the Alzheimer's societies do to try to address these challenges? But also what can healthcare systems, what can governments at different levels do to try to address these issues? I always get asked by media, like, what's the one answer? How do you solve this problem? It's way more complex than a single point. There's lots of work to be done, and I think we all have to work together to try to make things better for people. Again, I just want to conclude, we have lots of numbers, lots of projections. Those are what current trends. If they continue, that's what we'll see, but really it's about the people and the people that we need to support. So again, sharing those faces to conclude my talk. Thank you so much for your time, and I'm happy to take questions if there's any time left. Thank you. Sure. We actually have a chapter in the first report on caregivers, so some projections. Because of the model simulation, we can actually look at relationships between people as well. And so there's families within the simulation data. So we actually estimate caregivers within that. There's a whole chapter on it. So I think those conservative estimates, because of the way the data is modeled, it's only one caregiver for a person living with dementia. And we know that's not true at all. And also when people go into long-term care, we don't have caregivers attributed to that either, and we know that's not true. So they're conservative estimates, but still huge. So we could put some numbers on that from that first report, what the cost is for the Canadian pop-up. We highlight some of the challenges and issues, and just try to bring attention to what's the important role that caregivers play in dementia care in Canada. If we didn't have dementia caregivers, we wouldn't be able to. Our healthcare system would collapse basically because we wouldn't be able to manage it. In the next report on economics, you'll see more of that as well, because when you try to break down the actual costs, it's not just direct healthcare costs that you need to think about. It's also indirect costs, including people leaving work because they have dementia, or people leaving work because they have to provide care. On average, people provide 26 hours of care for someone living with dementia. And that changes across the time course of dementia, right? It might be less in the earlier stages, but more in the later stages. So with the growing number of people with dementia, you're gonna have the growing number of people providing care. So yeah, definitely good question. Lots more work to do. A lot of what we do at the Alzheimer's Society is support caregivers and giving them knowledge and resources to help do the important work that they do. Yeah. Thank you for the question. Great point. 100% agree. So I hope with this report we can get some attention. We have been meeting with some MPs at the national level, but I think it can't just be the national level. We also have to do it provincially because that's how a lot of our healthcare is organized. But yeah, I think just keep, how many times can we raise the flag and ring the bell to say it's coming? We've been talking about this for decades now. So how to get their attention, I'm not sure. We try, keep trying to think, keep talking about it, talk to your friends, talk to your family. Everyone, I think, needs to know more about it. If we keep, the trends continue, more and more people will be impacted by it. So then maybe that will get the attention of politicians as some of their family members are being impacted, which they already are, but might happen more so. But I think from my perspective, bringing the numbers, keep talking about it, take any meeting I can and try to share with them this data, and hopefully that will make an impact. The dementia strategy that you spoke of is actually finishing up this year. So we're hoping that we see some sort of renewal or increase with an election coming up. Maybe that could be an election issue. So I don't have a good answer for you, but I think we all need to try hard. We got 4 minutes left for questions. Yeah. I'm sure there is a lot. I've seen more and more talk about delirium and how that is an increased risk for dementia, especially in hospitals. I did my postdoc out at Dalhousie University with Ken Rockwood, who works in the hospital there. So he's talked a lot about delirium and trying to bring tools to individuals. So I'm not sure if the website still exists, but This Is Not My Mum. They developed that out at Dalhousie to try to educate people about delirium. It's an important topic. A lot of people don't know about it. People might get confused that someone's parent or whatever develops these issues when they have an acute care episode, and they develop these cognitive issues, and they immediately think it's dementia, when it's something that you can actually treat through whether it be hydration, nutrition, to address those concerns. So there definitely is research on that. I won't be able to speak to it today, but I know that is out there, and I see a growing amount of interest in this idea of delirium and more education that's needed for the public. Yep. So we've actually seen rates go down, right? So if you standardize for age, we've actually seen improvements in terms of dementia. If you think about it, we have healthier older adults, less smoking, more exercise, better heart health care. So those things really have had a positive influence on the numbers. But because we have an aging population, we'll see those numbers increase. When it comes to other conditions, because aging drives not just dementia, it also drives cancer, it drives heart disease, it drives many of the major chronic conditions. We'll see those also increase as well. So it can't really just be about dementia and brains. It has to be take like an overall more holistic approach to aging. How can we better address aging across the Canadian population? I'm a gerontologist though, so I'm 100% biased. Yeah. So it's a good question. It's really hard to actually figure that out. I shared some numbers here. It's a micro simulation model, not real data. Our government of Canada is really trying to do a better job at counting the number of people who live with dementia, but that's not we don't have a good count, really, a good real count. Trying to do better, I always thought this was easy to do, but it's not easy to do. We have different data systems across the country, different ways to count. Many people don't get diagnosed, so all of our estimates are probably under anyways, because many people don't even interact with the healthcare system. Compared to other countries, I don't know that data very well, but if you can look at different income levels, and I think there's a lot of interest going into like lower income countries because of the poverty, the impacts of nutrition, the impact of things like diabetes. You might see higher rates in lower income countries due to those dementia risk factors being at higher levels. But that's all I have for you today. Sorry. One more question. I think I saw it right here. Sure, yeah. So just to repeat the comment and question, so the economic approach might be the best way to get the politicians' attention, showing the costs that we're expecting to see. So we will get that with the next report, and you're right, that's probably going to get their attention more so. And with that report, similar to the first report, the impact of prevention, we'll look at different scenarios, and if we can push off dementia across the population, you can see the cost savings. So that might get their attention too, to do more prevention work. And in terms of worldwide initiatives, there's different layers to that, right? There's like the worldwide fingers, looking at prevention, so trying to do trials where you address multiple things in individuals and see how that impacts their dementia risks. So there's a group of people trying to do that across multiple sites. We have one in Canada, but all over the world. But then like things like Alzheimer's Disease International, trying to coordinate Alzheimer's societies, also trying to bring people together. So, and research is just generally, usually we're a global community, so there is some sharing. Here in Canada, we have the CCNA, the Canadian Consortium for Neurodegeneration and Aging. So that brings Canadians together, and then they can collaborate with international groups as well. So that's it for me today. Thank you so much.
You have Dr. Armstrong's Thanks, Francois. You have Dr. Armstrong's report in your white package. If you need additional copies, it's certainly available, Landmark Study Parts 1 and 2, on the internet at any time. If you need hard copies, if you need printouts, drop by the Alzheimer's Society. We're happy to provide them to you, or give us a call. We'll mail them to you. Always open to doing that. On the political question, the Alzheimer's Society of Windsor and Essex County is meeting with all three levels of politicians locally. It's an ongoing project we have underway under Ms. Hall, Karen Hall's direction as our board chair, meeting with all three of our MPs, Member of Parliament federally, all three of our MPPs. We're in very regular contact with our MPPs provincially, and that's where our funding is from, and also with the local politicians. So Windsor and the 7 municipalities in the county, meeting with the mayors, deputy mayors, and ultimately with all of the sitting city councilors and town councilors. That number all in is about 70 people, 70. Okay, so we have a process in place where we invite the politician to come and see us at the Alzheimer's Society. We present the landmark study, our national data, so that information is getting out there. Provincial data in concert with our provincial public policy office at the Alzheimer's Society of Ontario in Toronto, and of course our local data. And we have that broken down between Windsor statistics and the 7 communities in the county, inclusive of Peely Island, okay, and that data there. So, and then the elections will all come. We'll be in the throes of the 3 elections over the next couple of years or so, and we'll start with the people who come back and the new people as well. Okay, so thank you for that question. That question was from Dave Cook at the back, who is one of our honorary directors and a former government minister in Ontario, as many of you would know. Okay, so thank you again, Dr. Armstrong. That was wonderful. We do welcome to the podium Drs. Pandey and the future Dr. Dube. Welcome.
Thank you, Shelley, for the introduction, and thank you all for coming here. And before I go further, I must acknowledge the generosity of this community. In the picture, you might see a person who is Parkinson's patient. He's no more, Mr. Joseph Sachi, who generously supported our research with a donation of $150,000 to the project. And earlier he did it in 2009 and that has brought us to this stage. Of course, his donation was also critical for getting us funding from CIHR, Michael J. Fox Foundation. And I'm going to share some of the results from those projects too. And again, I would like to acknowledge 2 of my collaborators, Dr. Sikorska, my postdoc supervisor and group leader in Ottawa, with whom we developed a water-soluble coenzyme Q10. And she is at home, again had some problem, a stroke-related trouble. And second and most importantly, Dr. Cohen. He is improving slowly, I hope he comes out, but his enthusiasm for the project is unparalleled. Many of you may or may not know, Dr. Cohen is the spouse of a person who died of Alzheimer's disease, Anna. And I have been in touch with both of them very closely. So the stat, whatever you presented, Dr. Armstrong, I multiply that immediately by 2 because his spouse is the one affected immediately. And very few people can cope with that stress. Dr. Cohen is an exceptional person who wanted to drive the research and work very hard, donated personally to support this student more than $40,000 to this project. And with that, let us go to my presentation, and I will go like this. Oh, up and down. Oops, no. I need some help, technical support. Where? Yeah, I'm doing that. I thought with younger people it works better.
You can click on it.
On this one, okay. So our brain, the black box, and it's a complex of networking cells, and these are post-mitotic cells. These cells, whatever we got at birth, they live as long as we live. Please take care of them. Okay? They have their own system to take care, but still we can help. And what is the risk factor? These are post-mitotic neurons. They use 10 times more oxygen. Oxygen is nice, but as a biologist and molecular biologist, oxygen is one of the most reactive molecule. It produces oxidative stress. So we use it for energy, and we generate oxyradicals that causes us aging. And in unfortunate cases, excessive oxidative stress can cause dementia, neuronal cell death, because they live long, they accumulate damage, and that can happen. Again, brain cells have fantastic capacity. Since they live for very long, any bad protein, they get rid of that by inducing autophagy and so on. They keep doing it, but unfortunately, sometimes it doesn't work very well. So targeting oxidative stress in our research, targeting induction of autophagy cleaning process, and one more thing, inflammation is another risk factor. It is very nice anecdote I would like to share. Please don't take it medically 100% true. My friend is a neurologist, one of the very bright person, and I told him that, oh, my knee is paining and I got the x-ray and everything. Doctor says you have got arthritis. My friend says, congratulations. I said, what? Why congratulations? I said, you will be taking lots of anti-inflammatory drug. So knee is bad, your brain might be doing okay. So it is so much so true. Again, my emphasis is towards prevention of this. This is what we can do to prevent. Again, these are the sad numbers. I'm not going to go through. Already it has been made. So I'll be going faster. Symptoms, everybody knows. These are the brain sections, how they are there. Trouble now is, yeah, this one should be there, then there, okay. Thank you. This problem is, everybody is aware of that. A person, when diagnosed, we know that it's like a child walking towards the well and fall down. Everybody knows that. Everybody wants to help, but we are so helpless. There are medications or something to help with symptomatic relief, but that is it. Last 2 years, there have been an antibody development for the things approved. We don't know but that is only targeting the deposition of amyloid plaques. It's a multifactorial disease with 5 different etiologies. And so something to do prevention. I always tell, I teach a course in natural health product. And I keep telling my younger students, because those are the people, they will be in the duty when I will be on the stretchers. So it is important to educate them that they should be healthy. Invariably, most of natural health product, good food, colorful food, they have 2 properties. They are antioxidant and anti-inflammatory. Please eat them. You're going to keep the brain healthy. And other than that, don't hurt the brain, don't hurt others, and don't get hurt. Whenever we get hurt mentally, it releases also neurotransmitter, this and that, cytokines. It is not nice. Keep the brain healthy and active. We work our muscles to make good muscles for health, joints and everything. Physiotherapy can tell you. For mind, keep it active. If it is active, neurons are good. Now I'm going to tell you that we don't have anything at present to prevent the progression of the disease. Just because there are multifactorial, we are trying to target all these together. Inflammation, inducing autophagy, oxidative stress, and keeping the mitochondria healthy. Mitochondria is the sole energy provider for the neurons. And that's why they use lots of oxygen. Of course, protecting our synaptic connections. And one more very important thing for dementia or Parkinson's disease is, these are not overnight development of the disease and overnight cure. Over a long time they develop, they progress over a long time. Any medical interference you provide, if it is in single chemical targeting a single pathway, it is good for 1 week, 2 weeks. Over a long period, there are invariably side effects. So there should be something of nutraceutical categories which are safer to be taken over a long period of time. That is one of the focus of our results too, our research. So with that, in this one we are going to discuss first age generation, my presentation, then the future generation. Keanna will talk about the new things. Together, we are addressing one important thing, the early diagnosis of Alzheimer's disease. It is very difficult. People don't even, they always deny they have anything. Memory-related problem, it takes a long time. There is nothing like blood test which can tell you something. Recently, lots of advances have been made in MRI or brain scanning. That can give some information, but in early stage, we don't know. So for that, we are addressing that by using an MRI scanning of mice. At this juncture, I would like to really acknowledge the University of Windsor Faculty of Science to help us, and donation from Dr. Cohen, to get the MRI machine component for mice. So again, Keanna will be talking about this is a new technique. We are all excited about it. I think this is the first one in the southwestern Ontario. And we didn't know whether it will work or not, but she has some exciting results to share. that yes, we can monitor structural changes in the brain. Now, the second part is to develop a therapeutic option which is safe to be taken over a long period. I will be sharing some of the results at in vitro, and most importantly, target those structural changes and then behavioral changes. I'm so lucky to be in Windsor where I can collaborate with Dr. Cohen, who can talk to mice and find out what is the problem. I can't. They are behavioral scientists. They develop the assays for memory loss and so on. I do the biochemical cellular staining. And on top of that, structural change and imaging of the brain. With all three components, we are trying to address this. This is a collaborative project between biochemistry, psychology, and physics. These three never come together. I wish they all should come together. They can do wonders. With that, CoQ10 is a simple compound, very oil soluble. It is a component of mitochondria which develops energy. Our initial thought was if we increase the energy production from mitochondria, that can help the neuron. But when we take the CoQ10, put it into the petri dishes, it just floats. It's a water insoluble. And that is what happened in NRC. We developed a water-soluble formulation of CoQ10. Dr. Sikorska was key person in there. And when I moved to Windsor 20 years ago, I brought that as a dowry, that project in Windsor. And most of the things were done over here. So this is the mitochondria, which I call Chernobyl of the cell. If it works, fantastic. If it doesn't work, it kills the cells. So we have to keep mitochondria very healthy. And we believe CoQ10 can do it. I will show you some results. This is the water-soluble formulation called micellar formulation. I'm not going to go to detail. It is just soluble. It can be put in the water. You can drink it. And best part is it can get into the cells. So first, we wanted to test if CoQ10, water-soluble, can protect brain cells against oxidative stress. And for that, we did this experiment. This is the time-lapse photography. These cells are treated with hydrogen peroxide, oxidative stress. And you can see these are dying neurons. Then we did the second experiment in which we pre-treated those neurons with this water-soluble coenzyme Q10. This is a very old experiment, but almost astonishing result. And then challenge that with do you see any difference? It's as if it is not a movie. It is a movie. Nothing happened. Dr. Sikorska said, as if they are smiling at CoQ10. Come on, nothing will happen to me. It was absolute, close to better than 90% protection against oxidative stress. This is a still picture. This is glutamate toxicity, which is one of the reasons for Alzheimer's. And again, you can see the one UB-Salt Q10, QE is the name of the water-soluble formulation of that. You can see that, oops. So you can see the glutamate without protection and glutamate treatment with protection, black and white difference. So this was very encouraging result. And this is was another important finding. I don't know, you can see red color there in the picture. It is very bright here. The red dots are indicating healthy mitochondria. And we challenge the cells with H2O2, they disappear. Mitochondria become dysfunctional. But if you do the same thing in presence of CoQ10, mitochondria are protected. So all these results led to ask the next question. Everything works in petri dishes. Will it work in the animal model? That is where we were. And for that, we used the double transgenic mice. We know that there are certain genes which go wrong that cause Alzheimer's. So right now, people have made commercially available with 2 genes mutations put in the mice, and they develop the disease. And this is the standard model. I will be sharing you the results with double transgenic mice, mice with 2 defective genes. Keanna sees young people, she going for 5 mutations basically, and hers is most important and recent one. And this is a very simple experiment. you have these mice, one control, one treated with your material, drinking water, and one wild type healthy mice. Just compare these. So don't do that sacrifice immediately. Wait to how the disease progresses, monitor that in terms of behavior, memory loss. And keep monitoring both treated and untreated group over time. At the end, we sacrifice the animal and look into the brain. So first one is the testing. Again, it is very difficult. Keanna will be explaining it better. How do you know if the mice remembers things or not? There is a nature of mice. Anything new, it will be very curious to explore. Okay? But if it has good memory, it can figure it out. This is new, this is old. However, if the memory is gone, anything will come, it will find, oh, it is new, because it cannot compare. This is the result. Very exciting result with double transgenic mice published quite a while ago, where we see there is a wild type graph before and after. There is a little bit interest. And the middle one is treated one, transgenic mice, diseased mice, treated with CoQ10. These two look almost identical. Means treatment has brought the diseased mice to behave as if it is healthy mice. And the last one is untreated. Whatever exploration was there in the blue one before, and then when you, after 15 days, put the same object, it thinks it is new. So this is how memory was tested. Well, that is good. Let us see what is happening in the brain. Before we sacrifice again, we just measure the amount of amyloid beta in the circulation. So without sacrifice, you can take some blood from the mice, and there we find control. You see the amount in the first bar, and then the treated mice. And this treatment is not injection, just putting CoQ10 in the water. It's quite nice. It has decreased 50%. Wild type is healthy mice, no amyloid beta at all. Again, unfortunately, these are the stainings. And I don't know, the first panel is the Alzheimer's plaque, red color in the brain. The second one is treated. You can see the plaques disappear. In fact, it was so good, the reviewer said it is too good to be true. It is unbelievable. You have to use another stain. So we have to use anti-amyloid beta antibody to stain it. Wild type, of course, doesn't have. Here you can see similar results. Close to 90% inhibition of amyloid beta. Now these two, behavior and immunostaining, they're talking to each other. That is very exciting for us. Then we also use the same tissue to look for autophagy. Our brain, in healthy brain, this autophagy process is always active. Anything bad in the cells, it recycles it, digests it, and keeps it clean. You can see the wild type in the first panel. There is lots of staining for autophagy. In untreated AD mice, you can see that staining is down because that process is defective. Then the next panel is just the placebo, is also down. And then with UB-Salt QQ10, it is coming up. This is something we are very excited about it. People are trying to activate autophagy by this chemical, injecting something in the brain and so on. Here, a simple nutraceutical can bring up that one. We are excited about it. Now we conclude this part, and this is very simple, that this seems to be active. In the meantime, in 2012, a big PNAS paper was published in collaboration with McGill University in Canada and Indian Institute of Science in India, testing ashwagandha extract against Alzheimer's mice, similar to ours. And after that, there's a burst of interest, actually, so much so that ashwagandha can be found in the Walmart and Costco. Before 2012, nobody knew what is it. It is, by the way, called Indian ginseng too. It's a root extract. So we thought, why not combine them together? Two good things together. We call them tonic. I'm going to share some results with you. This is ashwagandha extract. It is used as an Ayurvedic mental tonic. And there are these chemicals. We have been getting the supply from authentic supplier, as well as we have got the phytochemical profile checked. So we have the quality control, and we use that extract. Again, all these results are based on staining. So you have to really see the red color staining, okay? So what happens? Simple, this is the fibroblasts taken from Alzheimer's patient, donated from. In that, we found that there is upregulation of oxidative stress, but if you treat them with Ubisol Q10 or ashwagandha or the tonic, the oxidative stress is brought down. So ashwagandha and CoQ10 both act as an antioxidant. This is the fibroblast, but now we are getting in the brain. This is the brain region, where we find that beta amyloid plaque. I would like to have your attention in the double transgenic mice tonic treatment compared to the untreated mice. I wish I had a way to see that. The bottom one is tonic, and that was the most effective. It was clear that combining these two has better implication, a better effect. Similarly, looking for the peroxidation on beta amyloid, again we checked. Lipid peroxidation is the indication of oxidative stress in the brain, and that is what we are seeing, that reduction of oxidative stress. And here we simply see the pro-survival astroglia activation by the tonic treatment. Our astroglia, there are microglia, astroglia. Astroglia get activated to protect the neurons. They secrete the neurotropic factors. Microglia are pro-inflammatory cells. When they get activated, they produce cytokines to cause inflammation. Here we do see astroglia activation in the tonic the best. Now, the BDNF is the brain-derived neurotropic factor secreted by astroglia to protect the neurons. And we do see that protection going up in the treated mice. Now, this is the latest result we have. In the literature, we found that many times they say neurons are intact, they are not dead, but they can't talk to each other. That is because the synapses where they meet each other, the connection, that has gone wrong. In the literature, ashwagandha has been shown to have improved synaptic health. We wanted to test that too. This is the synap25 protein upregulated, which means that there are better synapses. Again, in the tonic, we see the upregulation of synapses in these unhealthy mice or Alzheimer's mice, which is very interesting for us. And again, here we look for inflammation and autophagy activity here. Like previously, autophagy is upregulated. Again, all these slides are absolutely dark room, so I'm going faster. So at this stage, we have got this. We were funded initially by CAHR and everything was good. Now we are at a stage, this Ubisol CoQ10 is manufactured, produced by a company, Next Remedies. They have the copyright. We have the research right. They were about to fund a project under my tax for the next phase, which is going to be presented by Keanna. So we were asked, why not use the most robust, stringent model, 5 mutation mice model, and then use MRI for structural change, behavioral change for memory loss, and then do the staining in the brain, and show that if it is good for that. Everything was set. The grant was approved by my tax, but this company had no money. Unfortunately, we got stuck. And I had already, Keanna was on the project, another person who was a PhD student. But so at that stage, again, Faculty of Science, they helped us with $25,000 to make Keanna doesn't go hungry, with some money for the undergraduate student and graduate student, and start this project. So for the first time, we are going to share the result, preliminary result, because they have been just working for over each project, each experiment in Alzheimer's project takes 1.5 years. Because you take the mice, it develops the symptoms, so by the time you sacrifice and do the staining is long. So the current experiment is on. And again, I would like to acknowledge these young people who are working very hard for almost nothing. I counted their wages per hour. We would be arrested for illegal misuse, something like $4 per hour. But it is their enthusiasm for the field and passion for it. Again, Jerry is to some extent very responsible for doing that. So can I ask these students to get up, please, first, all of you. Gabby, Alaska. And they are going to do this experiment. Our university admitted Dr. Gurdon and Dr. Johnson is here. We pay $225 for each mice MRI. That's the cost. So Keanna is doing expensive experiment, but we are so excited. For the first time, there is something on 3 level which is showing to be positive. We are very happy to share. Thank you for your attention. Keanna.
Thank you. So, talk about what happens during the lifetime of these mice. So, let's first talk about what happens in the brain. Can everybody hear me? Okay. So, what happens with Alzheimer's is the temporal lobe is targeted first, which includes the hippocampus and the amygdala. So, these two brain regions are closely tied together, and they're very important for encoding spatial memories. So, one of the first symptoms that becomes apparent with somebody who has Alzheimer's disease is that they have problems with their spatial memory. As the disease progresses in the neurodegeneration, thank you. Better? Okay, good. So as the disease progresses and the neurodegeneration continues to spread to surrounding tissues in the brain, then non-spatial memory starts to become a problem. So when these neurons become sick and they have troubles communicating with each other, eventually they start to die off. And what happens to the brain is it starts to shrink. So the hippocampus shrinks, the cerebral cortex shrinks, and the ventricles become enlarged. So again, the problem is that there is no cure, unfortunately, and current pharmaceuticals, they can lead to harmful side effects and toxicity with long-term use. So we've also found that in current and previous literature that reviews novel pharmaceutical or nutraceutical options, they tend to look at just one aspect of the disease or one scientific discipline. So we want to solve this issue by proposing a novel nutraceutical option using a combination of water-soluble coenzyme Q10 and ethanolic ashwagandha extract to hopefully halt the progression of Alzheimer's disease. And the great news is that humans have been taking this already for a long time, and it's very well tolerated. And we want to evaluate the efficacy of this treatment through a longitudinal experimental design that follows the lifetime of the disease. So we are coordinating very closely with multiple departments in the university to get a big picture of what's really going on here and how this treatment is affecting these mice. So this has been, Dr. Pandey did a great job of going over this. So I'm going to touch on it briefly, but Ubizol Q10 and ashwagandha are very complementary for each other because, to put it simply, Ubizol Q10 heals the mitochondria and it helps preserve the structure of the brain and preserve the neurons themselves. And ashwagandha helps with the communication between neurons. So we are going to be testing this combination treatment using 24 female mice, 16 of which are transgenic. So these are genetically engineered to express human genes associated with Alzheimer's disease. And we're going to give half of these sick mice our treatment, and the other half, they are going to have no treatment. And we want to compare these two groups to just a normal mouse that has not been manipulated at all. So that's our wild type group. And we're going to be subjecting these mice to 3 repetitions of MRI neuroimaging and behavioral experiments. So the first phase takes place around the mild degenerative stage, the second phase moderate, and the third severe. So our prediction here is that the wild-type mice will remain healthy throughout their life, and the treated transgenic, if the treatment is effective, will be comparable to these healthy wild-type mice. Whereas the untreated transgenic group will continue to degenerate as expected with this transgenic mouse model. So the first component of our experiment is MRI, and it is very exciting. It looks a little bit like a mini fridge. It's about the same size, and it has a little drawer that we pull out, and we can put the mouse in there, and it's really cute. Everything's miniature. And I don't think that you guys can see, but I have a picture of our mouse wrapped in a little blanket there, because when they wake up from the anesthesia, we like to keep them cozy. Yeah. So what I find the most fascinating about MRI is, yes, it does show us the structural changes within the brain, but it also tells us a lot about the composition of the tissues within the brain. So first we acquire the image, and we use a T2 weighted image, which basically all of the bright spots in the image are tissues with high water content. So that would be cerebral spinal fluid and inflammation within the brain. So focusing on just the brain region, we can segment out those, the areas within the brain of the high intensity, and we can get a volume measurement of the cerebral spinal fluid volume, or the inflammation within the brain of these mice. And we can compare that between these different time points. So moving forward, we want to then compare the MRI to how their memory is acting. So we use a 4-arm plus maze, and we basically put the mouse in there, and we don't want to force them to do anything. We just want to evaluate their normal exploration. So we set up the maze with 3 objects in 3 of the arms, and after repeated exposure to the maze with this layout unchanged, we hope that the mouse will habituate to this environment. We hope that they will have a good memory of these objects in this location. Then, to test their spatial memory, we will take one of the objects and we will move it to a new location, to the previously empty arm. And if the mouse has not had their hippocampus affected, if their spatial memory is still intact, we expect that they would recognize this change in their environment, and they would increase their exploration of this object in the new location. Then we will test their non-spatial memory by swapping out one of those previously unchanged objects with a brand new object that the mice have never seen before. And again, if their non-spatial memory is intact, they should recognize this change in their environment and have an increase in exploration of this object compared to the previous habituation trials. So our exciting results for the MRI, our first set of results, we've currently undergone phase 1 and phase 2 of experiments, so mild and moderate stage. So in the first stage, you can see that, maybe you can't see, but the treated transgenic and the untreated transgenic had significantly higher cerebral spinal fluid volumes within their brain compared to the wild-type mice. But untreated transgenic were significantly higher than the treated. Now, moving to the moderate stage of degeneration, we can see this changes, where now the wild-type mice and the treated transgenic are comparable to each other. But the untreated have severely higher cerebral spinal fluid volumes within their brain. Now, when we compare between phases, between time points, we can see that the treated transgenic had a decrease in their cerebral spinal fluid volume. So they had a decrease in their inflammation within their brain, whereas the untreated increased and the wild type stayed the same. So this is very exciting for us, but we want to compare this to their behavioral, to their memory test as well. So to start with their spatial memory test, you can see that in both time points, all groups of mice did have an increase in exploration of the manipulated object compared to the last habituation trial. But when you compare between phases, this is where you can see an interesting trend starting to form. So you can see that the treated transgenic and the wild type mice have had an improvement in their performance of this test over time, whereas the untreated transgenic group have started to decline in their spatial memory. Now, with the non-spatial memory test, there's not a whole lot of difference between the groups, either between either phases or within either phase. This could be explained because perhaps right now at this moderate degenerative stage, their hippocampus is being affected, and that causes their spatial memory to start declining and to start becoming affected. Whereas their surrounding tissues, their non-spatial memory is still intact. So this is what is expected at this time point, which brings us to phase 3. So that is currently underway. I have a student in the lab right now actually collecting the behavioral results. So we are very excited to see how these results turn out, given that the first 2 phases turned out amazing. So after that, we will then move on to Dr. Pandey's expertise. We will be doing the biochemical analysis, and this basically validates that the biochemical mechanisms in the treated mice were preserved and the untreated mice were not preserved. And it also confirms all of our pre-mortem findings. So as has been said throughout this presentation from Dr. Armstrong, we want to repeat this study now with male mice because there are sex differences between the progression of the disease and thus the treatment of the disease. So in conclusion, the MRI results did show that there was a decrease in inflammation within the brain of the treated transgenic mice. And that relates to their cognitive memory test, where they actually improved in their spatial memory relative to the wild type mice, whereas the untreated started to decline in their spatial memory. So these preliminary results strongly support that this combination treatment may be effective in halting the progression of the disease within this transgenic mouse model. And we're very excited to continue this and see where it goes. So again, I would like to say a thank you and dedicate this work to Mr. Sashi for his generous donation towards our project. And I would also like to say some acknowledgements to all of my supervisors. I am such a lucky student. I have 3 supervisors. There's Dr. Pandey, Dr. Cohen, and Dr. Zhao for the MRI. And unfortunately, Dr. Cohen can't be here today, but he has such a strong passion for this project. This is everything for him, and I'm so grateful. So with that, I'd like to invite Dr. Pandey back up to answer any questions.
Excited as you are, as researchers, working with the best senior researchers of Pandey.
Yes.
And we're so happy it's happening in our backyard.
Yeah.
I'm glad you followed the lecture from Doctor. Early stage, where it's probably more amenable to be modified. You know, any disease, early intervention is the key for early diagnosis. So the question is, this protein can intervention, is it the same as what we get commercially in the store as the new one? No. I want you to tell us, where we get your secret, right?
Yeah. Yes. Before I answer your question, she says that she is very lucky to have 3 supervisors. But everybody is confused whether she is doing her PhD in physics, psychology, or biochemistry. No, it's wonderful to have these people working together with passion. I wish the next remedy representative was here who is manufacturing this material. It is a water-soluble formulation patented by NRC and produced by Next Remedies Inc. in Toronto. At this stage, only for research purpose, it is not in the market. You will see different formulation, gel formulation, this formulation. We have not tested them. So we don't know the efficacy of them. Availability is a problem. Okay. Ashwagandha extract. Ours is alcoholic extract. There are ashwagandha extract available in the market. We did not use any of those. We prepared our own. And you cannot extract at home with 100% ethanol. It is not allowed. So whatever is available in the market, you can take it, definitely. The advantage of these extracts are their multi-component mixtures, and we believe that multi-compounds target multiple pathways. And also, I would like to mention one more thing. There is, in your package, there is a pledge form. We know that keep writing proposal. Begging is one of our side job as a professor for money. This project, it is so unfair. It was funded very well by CHR Michael J. Fox in the earlier stage. Now we are in a stage where it's a preclinical. It has to go to next level. And we are struggling with the fund to pay for this student. Please donate. Your fund will go to fund not me, but these young people. Remember, these are the ones who are going to take care of us. So it's important. And again, I would say that we hope that this company start bringing this in the market soon. Sure. Yes, please. We could not test it. It was floating on the water. It could not be tested in the Petri dishes, nor given in the mice, to the mice in the water. We have not tested that. There was a formulation in the market from Belmara. We tested that. They claim that it is water soluble. It did show some good effect. Belmara Inc. It's called gold, liquid gold. That is the market name. But we did only a preliminary experiment. Our company was not very happy with that, so we stopped doing anything with anything else. Yes, please. Very good question. Everybody takes CoQ10 for the heart conditions, actually. It is good for heart and muscles. If we did any clever test on behavior about mortality and so on, we could have got, but we did not. Physically looking, the mice look healthy and normal. There are frailty measures that are developed for mice. I see. Yeah. At the later stage, the third stage, it could be. And also condolences to one of the mice who died.
We also dedicate this presentation in memory of one of our mice just recently passed away, unfortunately, due to, it wasn't because of the disease, it was, she was getting bullied in her cage, but yeah, sorry to bring that up.
Okay. So, but we have only 7 mice in one group. Everyone has 8, but it still is good for stat, actually. Yeah. But good suggestion. We'll follow that up. Any other question? Yes, sir. Yeah, that is fantastic question. One of the problem with the PNAS paper published in 2012, which brought ashwagandha in the light, it was in the fine print. It was 1 gram of extract per kilogram per day given to mice, which is impossible to be escalated to human. 70 gram of extract, which will be produced from 7 kilogram of the root. It is very high dose. So we worked around our extraction procedure. Their extraction procedure was with chloroform, ethyl acetate. We use biocompatible 100% ethanol. From 1 gram, we brought it down to 100 milligram per kg per day, which will be approximately 7 gram of extract, which is not that bad. We are hoping that combining with CoQ10, it can go a bit lower, but dosing is important, and this water-soluble coenzyme Q10, that is the key aspect. The coenzyme Q10 in the market, people have tested oil-soluble. It works at very high concentration. Maximum CoQ10 you can take per day by FDA is 1.2 grams per day, that's it. They did a clinical trial for Parkinson's using that oil-soluble formulation. It didn't do nothing. Because in vivo, preclinical work suggested they had to take, again, 100 gram or 38 grams per day, a 70 kilogram of patient. This water-soluble formulation was amazing, actually. This is how our project got funded by CHR, where efficacy was 6 milligram per kg per day. Unlike the existing formulation, oil-soluble, which was 500 milligram per kg per day. So their bioavailability, we have done complete details of that. It does crosses blood-brain barrier and goes to the brain too. It has been published. Thank you for asking that question. That was very important.
Okay, I think that's everything. I would also just like to acknowledge my fellow lab mates, my fellow students here. We have a few of them here today. So if you're curious at all or want to talk to us, please feel free to ask us anything after this. We will be around. So thank you very much.
A few closing notes. Thank you again to our researchers, Dr. Joshua Armstrong, Dr. Siyaram Pandey, the future Dr. Dube, and of course in absentia, Dr. Jerry Cohen. Thank you so much. I think if I saw Keanna randomly in public and didn't know her, I wouldn't peg her as swaddling a recuperating mouse in a lab. Might see her at a fashion boutique or what have you, but I would certainly peg you as a future Dr. Dube, indeed. Thank you to Art Windsor-Essex, wonderful venue, and Time to Go, local business, for the beautiful food provided to us today. Excellent catering as always. And we ask, feel free to stay behind and socialize and speak to our researchers, as you've said. The Alzheimer's Society of Windsor and Essex County is a charity. Feel free to contact us at any time. Consider donating your time, talents as a volunteer, your gifts of money if and when you are able to support us. And again, all information is there in your white package for you. A takeaway for everybody here today in terms of what you can do for those of us in the Alzheimer family, and we're all in the Alzheimer family, here locally, provincially, and nationally. We wouldn't be here otherwise. Consider yourself as advocates for our cause, for persons living with dementia and for care partners, and that is the language that we use in the Alzheimer family. Please speak to friends, family, members of your faith community and social groups, your neighbors, your colleagues. Spread the word about us, advocate, rattle the chains. In short, speak to all about the Alzheimer's Society. Landmark study number 3 of 3 is due out, Dr. Armstrong, January-ish, 2025. Let's say first half of 2025, all being well. Dr. Pandey, future Dr. Dube, Dr. Cohen, et al., your research will continue. I think we should be looking towards another research day in 2025 or 2026, and we hope to be able to deliver in that regard. Thank you so much for being here. Thank you.